Okay, I'd like to do just a few examples on finding the exact values on the unit circle using reference triangles. I know we did a lot in class today, but I want to make sure that you guys are comfortable finding these exact values. So the first one is the sine of, that's 7 pi over 4. So the first thing you want to do, so again, this is some ratio, right? This is your angle, right? This is what we're trying to find. And the first thing I want you to do is I want you to sketch, right, that angle. Where is 7 pi over 4? Now, if you're not sure where 7 pi over 4 is, that's okay. I go ahead and change it to degrees to help you. So 7 pi over 4. Now, I'm going to multiply it, right, by some ratio. It's either going to be 180 over pi or pi over 180. I want my pi's to cancel, so I'm going to have pi in the denominator. And then I have 180 degrees, right? Or if you want to write DEG, or write the word degrees, that's fine. So I know my pi's are going to cancel. Again, you can multiply 7 times 180 and then divide by 4, or 7 divided by 4 and then multiply by 180. Either way, you're going to get 315 degrees. Okay, so you know 7 pi over 4 is 315 degrees. So I know, okay, that's 180, 270, right? Let's just say maybe 315 is right there. Okay, so that's 7 pi over 4. And here is where the reference triangle comes in. Okay, you're going to, so your reference, okay, angle or triangle. I mean, we say reference triangle, right? There's your, okay, pretend that's a vertical, nice vertical line, right? Your height. There's your 90 degrees, right? So this is your reference angle, right? A reference triangle. And so what angle is that? I don't know, let's maybe call it alpha, since 7 pi over 4 is theta. So alpha is, well, I mean, we have 360, right? So if we stay in degrees, we have 360, right? That's 360. If I subtract my 315, right, what am I left with, right? Or 315 plus what gives me 360? And that's 45 degrees. So 45 degrees, right, which is pi over 4. Okay, so that's my little reference angle there. And the reason I want you to know that that's pi over 4 is because whenever you have, right, your 45-degree angle, okay, you know we're in the unit circle, so our radius is 1. And so we know from our triangles, right, that, right, 45, 45, right, if the radius is 1, I know that my height and the base are exactly the same. So the point that corresponds, again, this is this is on the unit circle, is, okay, so we have radical 2 over 2 comma radical 2 over 2, but we know this is negative, right, because our y coordinate is negative. So therefore the sine, the sine of 7 pi, that's a 7 over 4, is equal to, well, that's the y coordinate, so that's negative radical 2 over 2. Okay, so that's, let me just, I want to move quickly here because I don't want the video to be too long. Okay, so let's just leave that up there. The second one I wanted you to try is the sine of, let's try, oh, so many good ones. Okay, let's do the sine of negative 1080 degrees. Okay, so I want to know what that value is, that exact value. So I'm going to go ahead, oops, and I'm going to draw my, well, where is negative 1080, right? So, well, we can, divide 1080 by 360, right? And see how many times it goes around the unit circle, right? So, I mean, you can use your calculator, 1080, I'm actually doing it right now, right? 1080, that's what you would do, and then you would divide it by 360, and it's exactly 3 times, right? Because 3 times 360 is 180, but this is a negative angle. So again, I'm starting at the horizontal axis. So this is negative 360, right? Then another negative 360, which is 720, and then we have our final 360, that's our negative 1080, right? You don't have to change it to radians if you don't want to. This is actually pretty easy because the point, right, if we're assuming that we're on the unit circle, right? There's our circle. That point is 1 comma 0, so the sine of that angle, which is equivalent to the sine of 2 pi, right, or the sine of 4 pi, the sine, right, the sine of negative 1080 would be 0, right? Again, if I had the sine of, 4 pi or 8 pi, right, again, it doesn't matter. I should actually say, since we're doing negative angles here. Let me get my pointer. So here, this would be negative 2 pi, right? And then we would have negative 4 pi, which is the same position as 1080. Okay, so that's the two problems that I wanted to do. Again, the triangles that you're going to see, right? You're either going to have a triangle here, a triangle here, a triangle here, or a triangle here, right? There's your bow tie that I kept talking about in class, right? And your reference angles, right? In our case, right here was our nice 45, right? But these reference angles, right? These alphas, they can be 30, well, they can be anything, but 30, 45, or 60 are very special angles, because then we can use our 30-60 triangle, or 45-45 triangles that I talked about in class. Okay, so those are the problems that I wanted to do. Let's actually, okay, we have, oh, okay, I'll move that up. Actually, we have, I don't want to make this too long, because then it takes just too long to upload. Okay, this is fun. So let's do, okay, let's do cosine of 840. Okay, I want to know what the cosine of 840 is. So again, I'm going to, well, where is 840? And 840 is, well, I mean, again, we're doing the same thing. 840 divided by 360. Okay, well, we know 360, well, 2 full revolutions, right, is, okay, so we have our positive x-axis, and we're starting, right, here's 360. Another 360 would be 720. Okay, so 720, okay, I'm adding, if I add 90, I'm right here, right, which is at 810, right? So 30 more would give me at 840, right? So there's 184 degrees. So again, there's my, so what I want you to see is what this angle, oops, in red, what is this angle, right? If this guy is, right, we added another 90, right, or 720 to our 90, that gave me 810, plus 30 more, right, would give you 840. So the red angle, right, again, that's our reference angle, right? Well, that guy, isn't that just going to be, let's see, we have, right, there's our, oops, I didn't want to do that. There's my 90, right, plus my 30, so that's 120. So 180 minus 120, right, or 120 plus what is 180? And that should give you 60 degrees. Okay, so I know there's a lot going on here, so let me make it here, right? So there's our, right, our 120, right, which is, I mean, you can, that's our 840, it's in the same position. So we have our alpha here, which is 60. Now, this is a right triangle, so if this is 60, you know this is 30. We're in the unit circle, so it's 1. The opposite, okay, the opposite of 30 degrees is always half of the hypotenuse. So that's a half, and we know that's radical of 3 over 2 using the Pythagorean theorem. Therefore, the cosine of 840 degrees, well, the cosine is the x-coordinate, right, or the base of this triangle. So that guy is a half, right? If you, again, pretend that's a perfect circle. Our point, right, our point P that corresponds to, 840 would be, actually I should write this out, negative 1/2 comma radical 3 over 2, because our cosine is actually negative, because it's in quadrant 2. Okay, hopefully that helped a bit. I know it kind of went a little fast. Feel free to pause and rewind and watch this over. I want you guys to do well, and I want to make sure you guys practice finding your exact values. I'll probably make the video for the problem that I asked you to do in class, since we didn't have time to go over it. Okay, have a great Monday, everyone. See you guys on Wednesday.